Okay, so let's start our seminar. So today we are excited to have Dr. Gianluca Stringhini here. So he's a associate professor at the ECE department from Boston University. He also holds an affiliate appointment in the computer science department and the data science. So for his research, so he has applied a data-driven approach to better understand the malicious activity in the internet. And also he has collected and analyzed a lot of large-scale data sets and also developed novel and robust mitigation technique make the internet a safe space. So Gianluca has worked on understanding and mitigating malicious activity like the malware, like the online fraud, the influence operation, and also the coordinated online harassment. So he has received multiple prizes like the NSF Career Award and also multiple Best Paper Award. So, and he has published more than 150 peer review articles. Most of them are in the top conference, like the top 4 security conference, as well as the top measurements, HCI, and the Weibo conference. So yeah, let's welcome Dr. Gianluca Stringhini to give us the talk and present his research again.
Thank you for the nice introduction, and good morning, everybody. It's an honor to be here. So today I want to tell you about some work I've been doing in the space of improving the moderation of false information as well as influence campaigns. But actually throughout my career, I've been studying a number of malicious activities that happen online. So what I do in my research is typically data-driven. So I collect real-world data sets about a certain problem, and then I try to come up with solutions. So I've been working on malware detection, I've been working on online fraud, vulnerability detection, and so on and so forth. And I'm happy to talk to you about this later during my visit. But today what I want to focus on is really the problem of false information on social media. And this has become a big societal problem, and it's also very topical given that we have an election coming up next week. So we've seen issues with false or debunked medications being advertised on social media. We see state actors actually trying to push false information, and we see conspiracy theories and so on. So what am I going to talk about today? Well, first of all, I want to talk about how can we improve the soft moderation of misleading content on social media. And so these would be the warning messages that you would see on social media sometimes when social media companies decide to put them there. And then I will talk about multimodality, because obviously information online is not only textual, we also have images. When we look at image content, a lot of issues come up and challenges dealing with computational resources and so on. And then finally, I will talk about accounts that appear to be real people, but actually are inauthentic, they are fake, and they are designed to basically polarize discussion and so on, and they're controlled by foreign state actors for that purposes. And how can we detect those? So let me start with the soft moderation topic. And so you probably saw, many social platforms started putting warning labels for content that they consider to be false, or something that people should pay attention to, and so on. So we saw that on Twitter during both COVID and the 2020 election. We saw that on TikTok during COVID. Facebook has been doing it in a number of settings. That is about climate change, actually. So it tells you, you should check out this set of scientific facts about climate science, and then make your own decision and so on. So this is a popular mitigation against false information. but it's sort of softer compared to blocking the content. You know, there are concerns of censorship and so on. And it's softer compared to shadow banning, where you know, the content is still there, but it's somewhat hidden and people don't see that. Okay, so this is what social media companies have been doing. However, what we found is that this was done very, very poorly, at least by Twitter during the 2020 election. So what we found is that, you know, there was, for example, a clearly fake and debunked post about dead people voting in Michigan and so on, and it received a warning. But then a nearly identical tweet, or, you know, at least topical tweet, did not. And in fact, in our research, we found that only 4% of potentially misleading tweets of confirmed debunked facts about the 2020 election were actually moderated. And why is that? Well, we try to understand that, and I'll show you some statistics later, but what we believe is that this is heavily human-driven. So there are human moderators who have to actually check and put these labels, and obviously they have limited resources. Okay? So what we wanted to understand is, can we actually learn from content that has been soft moderated already, let's say this post, and automatically flag more candidates for moderation. Okay. So this is our goal. This is our ideal pipeline. So when I give talks on these topics, people always ask me, you know, how do we decide what is true and what is false? You know, how do we determine what is misinformation and what is not? Consensus could change over time. Well, we don't do that. We focus on the technical part. So we actually rely on authorities, fact-checking agencies, and so on and so forth. We've also collaborated with domain experts, you know, public health experts, and climate change experts and so on, as I will show you later, to actually develop some of these data sets of, you know, what is the scientific consensus and what should we be looking for on social media. And so what we are trying to develop are a set of systems that can actually, based on these claims that are developed by someone else, can actually match social media posts to those claims and finally come up with labels, okay? And ideally, we want to do that as granularly as possible. So we want to identify the specific claim that is false instead of just a broad topic. You know, what Twitter used to do during COVID, any post mentioning COVID would get a label, including posts from health authorities, including posts that were sort of unrelated, posts that did not contain misinformation. And because of that, everything they could include as a message was just get the facts about COVID-19, right? So that's not very granular. It's not very informative. And as a consequence, people would just start ignoring it because they see it all the time, and so on. Okay, so can we, through these more granular systems, enable the development or more precise labels, essentially? So we started with this idea. So we have text. We have text that has been labeled, and we have a lot more text that has not been labeled. Can we develop an automated system to actually identify more candidates for soft moderation and help content moderators flag those? And so we developed this system called Lambretta, where basically we have a tweet that was moderated by Twitter. We have a set of tweets that we don't know anything about, and our goal is to come up with more candidates for moderation as accurately as possible. And this was published at IEEE Security and Privacy 2023. And the idea here at the core is that we frame this problem as an information retrieval problem. So in information retrieval, think about search engines and so on. Typically, you have a query and you want to find the optimal set of candidates that match that query, okay? So we want to do the same thing, given a tweet, how do we find the most relevant tweets that still talk about the same topic? And we experimented with a set of techniques. There's keyword extraction techniques. There's more advanced, semantic techniques like word embeddings and so on. We found that they're not working very well in this space. So we resorted to learning to rank, which is actually a technique that's popular in information retrieval. And the goal here is to learn a function that actually ranks the effectiveness of a set of keywords in retrieving the relevant information. So the goal is to find the optimal set of keywords, okay? So we take a tweet and we extract keywords from it. So we basically do all permutations of keyword or combinations of keywords in there. And then we have an evaluation data set that we labeled ourselves. So that's a ground truth. And then based on those keywords, we retrieve the candidates that contain those keywords. And then we extract a set of features. There is more there in the paper, which are sort of identifying what is what's the quality of these results. And our goal is to identify the optimal set of keywords that are relevant compared to those that are actually irrelevant, okay? And so, as I said, learning to rank is a well-established technique. There are many approaches to performing that. We find that the best performing model is random forest with lambda mart. MAP is mean accurate precision, which is a well-known metric in information retrieval. And so we have this labeled data set, we train our model, and then after this model has been trained, it can actually perform on claims that we haven't seen before, which is sort of key. Otherwise, we would need to update it all the time. So our ground truth comes from a data set of tweets that were soft moderated by Twitter during the 2020 election. These are related to the 2020 election, election denialism and things like that. And then our document store, so the tweets that we don't know anything about, comes from two sources. One was from that period, so there is this data set that was developed based on keywords that might have been related to voter fraud or not. They were in general related to the election. And then we also have the entire Twitter archive, or at least the sample that was freely accessible back then, to sort of identify false positives, false negatives, and whatnot. So as I said, when we compare our model with existing techniques, our model works better. So here we have the claims to be moderated. So these would be the tweets that received moderation. And then we have an F1 score, which is a metric of precision and recall. So it sort of depicts or embodies false positives and false negatives and so on. And we have some keyword extraction methods. We have some semantic search methods. We have BERT, so that's based on embeddings and so on. And we find that our learning to rank is consistently outperforming those. So for we have 80% or more F1 score for most of the labels, and actually it's lower is better in the curve. The second best performing method is Rake, which is Yake, which is a keyword extraction model. And so obviously false positives are always a problem, and we will always have false positives, and those are the main concern of social media companies. So talking to social media companies over the years, over a set of problems, fraud detection, spam detection, phishing detection, whatever, their main concern are always false positives. So they don't want to flag benign posts as malicious. They don't want to suspend their users for no reason and things like that. So it's reasonable to assume that a human moderator would need to be in the loop, right? And make the final decision, yes, this is bad. No, that's actually a mistake, and so on. However, even then, we find that the number of tweets flagged by our model is much lower than those flagged by the second best performing one. Okay, so we would reduce the number of candidate tweets that the human moderator would have to go through by over 5 times. Okay, so that's sort of making their life easier. So this is on our labeled data set. So this is based on a 5-fold cross-validation and so on. But as I said, much of what I do is data-driven, and I like to have real-world data to test it on. That was real-world data as well, but at least we knew what we were looking for. So what if we don't know what we're looking for? And so we tested our system on our entire data set. And out of 4 million tweets, our system flagged 101,000 as potential candidates for moderation. And after manually inspecting a sample, we estimate that we have 3.9% of those as false positives, okay? So we still make mistakes. That's why we cannot fully automate this. Looking at false positives, our false negative rate is 18%, so we still miss some tweets, maybe because the keywords are not perfect. So we are looking for a combination of keywords, maybe some are missing, but the tweet is still misleading. But that's still much better than the second best performing approach. And then we use this data set to estimate how good was Twitter's soft moderation during the 2020 election, which I already gave you a preview of. So we only find that they moderated 4.31% of the tweets containing election misinformation in the entirety of the tweets. And then we started wondering, why is that? A reasonable answer could be that, not all tweets are created equal. Some come from very popular accounts, and so they will be seen by everybody. And some come from some account with 10 followers. Maybe that's not as important or whatever. So we tried to validate this assumption. We found that that is not the case. Actually, the tweets that were unmoderated are more likely to come from more popular accounts than the ones that were moderated. What about exposure? If a tweet is retweeted many times or is liked many times, it's likely to appear in more people's timelines. Again, we found that that is not the case. Actually, more popular tweets were less likely to be moderated by Twitter. So obviously, we don't have an answer on why that is. It's sort of painting a puzzling picture because it looks like more popular content was sort of not moderated as much. It's somewhat counterintuitive, but that is what it was. We found the same thing when we looked at images, which I will tell you about in a little bit. Any questions so far? Yeah.
So I'm not sure if this is coming up, but have you considered the bias aspect? I mean, we're relying on the fact-checking people. So suppose there are 1,000 articles that was related with Trump or did mention the word Trump.
Yeah.
So if we use like tokens like Ngram tokens, so if the next news comes up with the word Trump, so I mean, will that model be biased?
Yes, so the fact checks are statements. So there would be a sentence of something that didn't happen, right? Or that was debunked. Okay. So that's what we use. In general, there is a problem of bias, yes. We try to mitigate that in some other projects. So when we were looking at image-based misinformation, one of the things we did was, okay, let's not consider any ground truth. let's find similar images and then let's look at them and label them. And I don't have time to cover it today, but what we found is that, for example, there was a lot of COVID misinformation coming from the Republican side as well as the Democrat side. They were just different types. So, for example, Democrats would mischaracterize the Trump administration's response to COVID instead of talking about conspiracy theories and so on, but it was still misinformation. So that was the way we tried to dig deeper into that. And another big problem I will talk about is that we don't have a good sense of satire and things like that. So you might have false statements, but they are clearly meant as a parody or satire and so on. And these automated models do not pick up on that. Yeah. The problem we have here, so what our learning to rank was doing is identifying topical candidates. So those were tweets that had a similar topic or same topic as something that had been debunked and therefore should be moderated. However, tweets are contextual. So if you're talking about a topic, it's not granted that that tweet itself is spreading misinformation. You might want to debunk it. You might be debunking that message, right? So you have 5G is responsible for coronavirus compared to 5G does not cause coronavirus. What Twitter was doing there was that any tweet containing 5G and COVID would get a flag. Very simple, but also not very effective. Also, if some health expert would say that 5G does not cause coronavirus, they would still get a label, and that could affect the perception that people have, and so on. So what we found is that Twitter actually, in this context, moderated 29% of tweets that were actually debunking false information. And even our model, Lambretta, moderated 20% of tweets that were actually debunking the misinformation because it was only looking for topic matches. So we call these contextual false positives. And we want to understand, can we automatically filter those out? And so we frame this problem as a stance detection one. So we have positive stance towards a claim and negative stance towards a claim. And we evaluated many stance detection models. That is a popular topic in natural language processing, has been studied for a while. But we found that they fall short for this purpose. For once, they're not quite granular. So if you look at, climate change isn't real type of claims, they fail to flag more granular claims that are identifying specific claims or evidence that climate change isn't happening. Like that, ice in the poles was melting before, whatever it might be. And also, they are not claim invariant. So we want our model to work on different claims that we haven't seen before. And most importantly, to work on different platforms with different characteristics and different affordances. So typically, tweets are very short. On Reddit, you have much longer posts. Will that generalize? Okay. So what we did, we developed a new system, a new technique called contrastive textual deviation. And this was published at Usenix Security this year. And so what we did here, we leveraged large language models to basically tell the language model what the scientific statement is. And then we use two contrastive markers, and we found that this works very well to ground the model and prevent hallucinations and give accurate answers, where we show a positive example. So this is an example of a social media post supporting that misinformation or that consensus, and the other one is refusing it. Okay? So our prompt looked like something like this. Classify if a statement supports or refutes the consensus, which is what we get from climate scientists or health experts and so on. This is an example of refuting, this is an example of supporting, and this is what I tell you, what I ask you to classify. And we use Flantify for this model, which is a model by Google. And so we found that just by prompt engineering, it works fairly well. Then we fine-tuned it, and it worked even a little better. And we compared it with many stance detection models, showing that this outperforms all of them, at least for this type of task. And we developed several datasets here. So the election denial one was the one we used for the previous paper. We only had a small number of labeled tweets there because we needed debunking and supporting. We developed a dataset of climate skepticism. This was together with climate experts and communication scholars and so on. And then we used two more, one related to COVID that comes from other work and one related to stance detection in general. So it wasn't related to misinformation, but we wanted to see, would that work? And so some of these data sets come from Reddit, some come from Twitter. And so that is also showing that our model can generalize between them. And we have all the results in the paper. And then we wanted to integrate the system with our Lambretta system. So basically we put it downstream after our topical matches are retrieved to basically filter out contextual false positives, okay? And so what we found when we consider contextual false positives instead of just topical false positives, Lambretta actually has a 20% false positive rate. By adding our contrastive textual deviation, we are able to reduce that to 2%, so by a factor of 10, while having a very small impact on false negatives. Okay, so that is clearly improving here. And here are some examples of the false positives that we filtered out. This was a misleading video as proof of voter fraud, but actually it's explaining later on what was happening. And this was something about the voter turnout in Wisconsin, and somebody's explaining that Wisconsin always had a high voter turnout, and so on and so forth, right? So these are not supporting the misinformation, but are rather explaining what was going on, okay? And so they shouldn't be flagged. So based on this, we are able to identify topical matches. So we improve the set of candidates by a lot compared to previous systems. We improve stance detection by a lot. So we have a good set of candidates, but we still find that we are missing when we look at satire and parody and so on and so forth. And that's a very difficult problem, especially for a machine to understand. So that's potentially an area of research that should be looked at in the future. So I've been talking about text so far, but actually on social media we have a lot of images that convey information and so on, and they can also convey false information. We see images, this image was edited to be like that and was shared on social media. We see false images in war zones, which are not portraying what they're supposed to portray. We see screenshots from news shows, and so on and so forth. What we found is that the soft moderation of images on Twitter during the 2020 election also was not very comprehensive. So this is an electoral map that allegedly had been shared by some foreign press. but actually never happened. It was just, you can go to interactive electoral maps websites and make your own. Only one of those was flagged by Twitter. So we found that only 7.34% of the potentially misleading images were flagged. A little better than the text, but still not very high. And so we wanted to develop a system able to flag these images. And so we have a series of papers that look at image embeddings and perceptual hashing in particular to identify similar images and so on. That's the technology that social media companies are using to identify child abuse material, for example. So the idea is that you have an image, you split it into quadrants, and each of them is identified by a token, and then it becomes a hash. So it becomes a vector, and then you can compare vectors very easily. And the idea of perceptual hashing is that, compared to regular hashing, is that if you change small parts of the image, the hash will still be similar, although not the same. So you can do clustering, you can find similar images, and so on. So we took this idea and we combined it with vector databases, which are supposed to perform very well for vector operations. And so that allows us to query hundreds of millions of images in a matter of in a fraction of a second. And then we find similar images, and those become candidates for soft moderation. Except that we found that a major source of false positives come from the text in those images. For example, you could have something like this, that's a news show. It's talking about the false claim of dead people voting and so on. But then you can have another image, similar but slightly different, with the same caption, or an image from the same show that's talking about something different. Okay? So what we are doing is actually using OCR, optical character recognition, to extract these, and then we look at similarities to those. Another popular example is just a picture. You could have an official picture of a politician, and then the text overlaid is what makes the misinformation, right? So it could be something completely harmless, it could be something harmful, and so on. So that's what allows us to filter out some of these. So we compared against many techniques. Some of them are syntactic hashes, so perceptual hash by itself. Some of them are more semantic, so they look at what is in the image, they look at important regions in the image, and so on. And we also compared with CLIP, which is one of these vision transformers, multimodal, that you can query it and it tells you what's in the picture or things like that. We found that our technique, pixel mod, outperforms all of them for when it comes to F1 score and recall. The precision with p-hash is a little bit higher. So basically, by introducing this OCR analysis, we can reduce the thresholds required by p-hash and improve recall. So that's one of the advantages here. Otherwise, you can only identify images that are very, very similar. But we also find that our system is slower, at least when the OCR is triggered, okay? Because it's heavy, it's expensive. However, if you look at all the images in our dataset, only 1 every 100 of them triggers that, because most images are not similar, right? So we have a slowdown of 0.2 seconds every 100 images posted on Twitter, let's say, if Twitter was using it as at scale. So we believe that that is acceptable. So then again, we ran this in the wild. So we built a query set of 959 2020 election related images that were moderated by Twitter. So we did that by hand. And then we queried our image index of about 20 million images. And we retrieved 40,000 tweets with images that were visually and contextually similar. Okay? And we found that 0.99% of those were false positives. And again, we looked at how many images Twitter actually moderated in the first place, and we only found 7% of those being flagged. So, this kind of automated techniques could improve that significantly. Any questions? Okay. So the last topic I want to cover now is this idea of online influence campaigns. So we're not looking at moderating content anymore, but we're looking at activity of accounts on social media. So I started studying this a while ago. So this was during or after the 2018 midterm election. And so the idea here is that state actors will carry out influence campaigns to shape online discussion. And there is, news reports of people working out of this building in St. Petersburg, that will clock in the morning, that will be given a set of topics to talk about. And they will be using each of them several accounts and, pretend to be real people and interact with each other and whatever, with the goal of pushing those talking points, spreading disinformation, polarizing online discussion, and so on. And so we started by analyzing a dataset that Twitter released in 2018 of accounts that they took down because they found them to be part of these influence campaigns for Russia, one of them, and Iran, the second of them. And then later on, they expanded it to many other countries. And we started to look at what did these accounts actually do. So we looked at the topics they were posting, and this is, you will probably not see it very well, but these are graphs made from word embeddings of similar words used by these accounts. The Russian-sponsored accounts were talking a lot about contentious issues like Black Lives Matter, police brutality, and so on. But they were also talking about politics, sports, and so on. The Iranian ones were mostly talking about Middle Eastern issues and so on. We also found that these accounts were often reused in the sense that you have a Twitter account and creating a fake account is the most expensive action that you need to perform if you are a malicious actor, a spammer, or whatever, because you need to go through all the detection mechanisms that would identify your account as being fake. So if an account is already there, it's much easier for a malicious actor to use it for a while under a certain identity and then reset it completely. They delete all their tweets, they change this identity, and they start posting something else. So we found evidence of the Russian accounts being used for Ukrainian issues in 2014. So when Crimea was annexed and so on. So they pretended to be Ukraine people. And then they reset and they suddenly became US people. And they started posting about US politics. Same account, same ID, and so on. Okay, so this is just to give you an idea of what we are talking about. But then we looked deeper, and this was on Reddit. The previous was on Twitter, this was on Reddit. And we wanted to understand how do these accounts operate? And we wanted to understand, how do they polarize online discussion? And so we found, this is an example. So this account was in the dataset that Reddit released, so they identified it as a troll. This one was deleted, so probably it was malicious as well. And this one is one that later on our system flagged. But basically we can see how these accounts are taking different sides of the discussion. trying to polarize it. Somebody might be in favor of an issue, some might be against it, and then they, call each other names and accuse each other of racism and so on and so forth. And the goal is that real people looking at it will engage, and eventually the whole conversation will be derailed, okay? And so we found that these accounts interact with each other a lot more than regular accounts on those same subreddits would, okay? And so we can use this as features, as indicators that these accounts are actually inauthentic, okay? So we developed a system called troll magnifier, and the idea here is that we have data, accounts that we know to be bad, and then we have all of Reddit, and we look at accounts that we first pre-filter. We'll only look at accounts that ever interacted with each other. And then we have a detection model where our features are, how much did these accounts interact, what topics did they talk about, and all these kind of things. And we train a random forest classifier to identify more of these accounts. And so we found that this works very well. We have a 97.8% F1 score on a 10-fold cross-validation. And we were able to identify 1,200 accounts that we believe are or were troll accounts. So we got very excited. We contacted Reddit about it, and we never heard back. So we couldn't confirm it through them, and so we started looking at other indicators. We found that many of these accounts were created on the same day. We found that many of these accounts were later suspended or deleted some of their posts. Remember that one of the main indicators of this kind of troll accounts on Twitter was that they would reset their timeline every once in a while and change identity. So we found indication of those for 66% of these accounts. And the remaining ones still show a high degree of synchronization. So we find that we were active at the same time and so on, and I will show you a graph in a moment. But also they were discussing the same narratives. So as I said, they were active on politically contentious topics. For some reason, they were also supporting cryptocurrencies very heavily. So they were promoting cryptocurrencies on cryptocurrency subreddits quite a lot. And that might be part of the reason, might be that they wanted to appear legitimate. So, if I'm only posting on topics that are of concern, that's not what real people do. You post on a number of topics, and some of them happen to be inflammatory or whatever. So this is a distribution of the post and the time where they made them. So the orange line are regular accounts that we did not detect, and you can see how they're pretty much uniform. The known trolls had some spikes here and there, and our accounts have some of those spikes as well that overlapped. But basically, you can see how this bursty activity is indicative of some campaigns going on. And then, perhaps more interestingly, we found that the activity that these accounts showed beyond the topics that we were asked to talk about was similar. So these are 3 accounts. One of them was identified by Reddit, so this was in our ground truth, and these 2 we detected. And so these accounts were constantly posting pet pictures on specific subreddits. Why? Because that's what regular people do. So if you're looking at one of these accounts because they are suspicious, you go through their post history, and then you see, oh, they're actually posting cute pictures, they're posting jokes and whatever, so they're probably legitimate. But if you put them together, you start seeing patterns. You have all these accounts that are acting, pushing the same kind of campaigns, and they're also doing unrelated stuff, but it's all the same stuff. And so what we believe is that they were given instructions on how to appear legitimate, and we were just following a script. Okay, so that is not something that you would expect to happen in a normal scenario. So to conclude, and I just got the warning, so perfect on time. I showed you how computational methods can be used to improve the moderation of misleading content on social media. And I showed you how these interaction patterns could be used to identify state-sponsored troll accounts. And this is a more difficult problem than simple bot detection, where we can find precise synchronization patterns. You know, I press a button and all my bots will send spam type of thing. These are real people controlling a set of accounts to make them look benign. So it's a sort of loose coordination. And obviously this is a moving target. So every time we develop a mitigation, adversaries will try and evade it and evolve. So, you know, we are not solving the problem, we are sort of just raising the bar, and we will need to think about where to go next. And with this, I'm done and I'm open to questions.
So thank you, Gianluca. So any questions?
Can we go back to the slide with the number of trolls detected? Or, one ahead of this. Whatever the graph is with.
This one?
Yeah, that one. correct.
Yeah.
So prior to 2015, there's very relatively low spikes compared to after 2015. So did this only really become an issue during 2015, or did we only just start to like?
So we saw that on Twitter before. So this is Reddit.
Okay.
So on Twitter, they started being active during the Crimea War. So that was 2014. And then they sort of resurfaced during the 2016 election and 2018 election and so on. It looks like on Reddit, they started a bit later. So it was 2016 election and 2018. I guess, you know, different platforms were affected differently. Yeah.
Okay, thank you.
I was wondering, I noticed that when you're working, you try random forest a lot.
Mhm.
And is that like a standard for this kind of work, or do you try more advanced models, or is it like a diminishing return? Like it's not, it's.
It really depends. So for supervised learning, oftentimes random forest works well. It really depends on the kind of problems you have and on what your data looks like. You know, how noisy is your data, and so on. Yeah.
Did you try other models, or was it
Yes.
just like?
Yeah. No. We tried a number of models, and that's the one that worked the best. Yeah.
Yeah, I think so. We also like for my research, we also like have some like for this malicious content detection. We also surprised to find that eventually random forest is indeed the best model.
It's oftentimes yes.
Yeah. So any other question? I think this is very interesting and also very important topic. Yeah, you can think about that if you have any question. I think the next week is very important. It's the election week. So I think so we will have a lot of misinformation.
Yeah, one of the issues is that many of the platforms shut down their data collection pipelines a while ago. So it's more difficult to monitor this.
Yeah.
You can still get Reddit data, but it's sort of rate limited. They got very concerned when you know, OpenAI and other AI companies started training on their data, like without limitations, and yeah.
Any question? Okay.
Have you considered utilizing any of the approaches you developed for like AI text detection or image detection? Because that could be used as a form of misinformation.
Yes. We are looking at AI generated content right now for images specifically. So that's definitely something that is important, and it's probably at this stage it's probably fairly easy to detect. So AI generated images still look different than to a human eye at least. But again, that's a moving target, right? So that will probably become more and more realistic. Even in maybe 3-4 months from now, it will be much more realistic. Yeah.
Yeah, so that's also like refer to like full-time thinking. So you introduce like as a three-line of research. One is text, another is image, another is the activity.
Mhm.
I was thought about you combine them together.
Yes.
I think it can make it more robust.
Yes. Another question is what if you might have a very generic image, but then the text in the post is what makes it misinformation, right? Yeah.
Yeah, and also like nowadays, like the generative AI is very popular. Like if you want to detect the image or like detect the text, for example, you can for your text, you can let it to generate the image,
Mhm.
and then you detect the image.
Yeah.
Yeah, or like for the image, you let it transform to the text.
Yes.
Put them together, so you
Yes.
will have more source like to use.
Yeah. That's something that spammers used to do by hand. In email spam, you would have the text, and then people developed the first classifiers for spam detection, and then the spammer started substituting some parts with images, with text in images and so on. Now you can do that automatically,
Yeah.
and you can even try to add some perturbations, not look exactly the same, so it gets even trickier.
Yeah, that's true. Yeah. So another question is that I saw for your Guangzhou's data actually is very small data set. So I'm curious that like why this small data set is can capture all the pattern, so it can be used to train a good model, like to classify more like text or image. Like I remember for your text classification, you only have 20,000.
Yes. So for the learning to rank one, what we are aiming to learn is really just the mapping between keywords and results. So you don't need too much data for that. For the stance detection one, we fine-tuned the model. We didn't train it, right? So it was an LLM that was already trained, and we fine-tuned it for stance detection. So the data set you need is still on the smaller side.
But if this is just a small set of Guangzhou's, how about if we have a conceptual drift?
Mm-hmm.
And then how to handle?
So for the stance detection, so the datasets we covered were very different. One, the Stansiosaurus one is not even about misinformation, it's just about general topics. And we showed that our system still works well. So we are quite confident that it's robust in that sense. But then, it can also always be tested more. All of this is open source, so you can get the code, you can get the data, the label datasets we developed, we released, and then you can build on top of that or whatever, reevaluate.
And for this text and image-based solution, like have you thought about how to handle this conceptual drift issue?
So the conceptual drift would happen if topics change. So what typically works if you are not looking at topics, but you're looking at other characteristics, like the interaction patterns, or how is the image constructed? How does it look like instead of just the what is in the image? That could be one way, yeah.
Yeah, I see. Thank you. Yeah, we still have some time, so I would like to ask some questions, or not related to this talk, but good to our students, all here are the PhD students. So I think for you, you are very successful research. You publish 150 articles. Most of them are in the top conference, top for security conference, top web conference, and so on. So can you share some like experience or give some suggestion to our students how to do the good research, how to produce the high quality like article?
I think all this advice. I'm not sure how much it generalizes, so it might work for some people and not for others. I think in general, what I do, I try to identify topics that are important to for society, but also that I'm passionate about. So if you work on something that you're really passionate about, it's easier. You will get stuck because everybody gets stuck, but at least you will have more more motivation to continue. In general, I think it's good to pick up on signals. So if you're reading papers from your field and you sort of identify what is the next big thing, what do you think has potential and so on.